Section 2.3, video part 3. We're now looking at equations, our third part. Remember we did ordered pairs in the first video, domain, range, and function. Second video we did graphs, domain, range, function. Now in this third video we're going to look at equations. Now, going to do a couple things different with equations. First, what we're going to do with equations is I'm not going to do the domain and the range and then do function. I'm going to do the function part first. So you don't have to write this down yet. So remember, when I say the equation, I mean this thing right here. So if I give you this and ask you, is it a function? How do we do that? How do we do the domain and how do we do the range? So see, you can't do it using the previous definitions that we used because you're talking about something completely different. I mean, you can't do the vertical line test on an equation. You can do it on a graph, you can't do it on an equation. All right, so how do we do this? All right, we're going to do the function part first. Then we'll do some examples. Then I'm going to do domain part next, and we'll do some examples. We do not do range of equations in here. We do range of graphs and we do range of ordered pairs, but not range of equations. So let's talk about equations. Let's talk about functions first. Take this note down. I know it's not going to make any sense, but take this note down and then I'll explain it. An equation in two variables is not a function if the y variable has a highest power that is even, or if the y variable is inside absolute value symbols. Now, let me basically restate that again, and then I'll show you why. So all you got to do is memorize that note. All right. First thing is this. When you look at your equation, look at the y variable only. If your y variable has an exponent on it, look at the biggest exponent in that problem that's on y. Look at all the y variables and look at the biggest power. The biggest exponent, if it is an even number. So in other words, if your biggest power of y is a 2, 4, 6, 8, 10, etc. Look at the biggest power of y. If it's an even number, it's not a function. So if your biggest power of y is 2, 4, 6, 8, etc., that's not a function. Second thing is, look at your y variable. If it's inside absolute value symbols, it's not a function. Those are the only two cases that you have to watch for. All others in this course, they will be functions. Okay, let me just show you this right quick. And there's a much deeper mathematical explanation I could give you for that, but basically for this course, that's all you need. Okay, so what two things did I say could not happen? Number one is your biggest power of y couldn't be even. So let me show you why. Look at this problem right here. Look at the y variable right here. Look at the power. That's even. So this problem right here, no. It is not a function because the biggest power of y is even. Now, if that was y to the third, it'd be yes. If it was y to the fourth, it'd be no. And so on. Now, let me explain why. You don't have to write this. I just want to show you something. I want to solve this equation for y. So I'm going to subtract x across. This is y squared. Now, how do I get rid of the y squared? You have to take the square root. But whatever you do to one side, you have to do to the other. Now, what did we say earlier when you take the square root of both sides? what do you have to put? Plus or minus? Now, why do we have to put the plus or minus? Because you took the square root to get rid of the square, because that's even. Now, here's the reason it's no. I'm going to pick a number for x. I'm going to pick one that works out easy. I'm going to let x be 0. Look at what I get y to be. If I let x be 0, 9 minus 0 is 9. What's the square root of 9? 3. But it's got what in front of it? A plus minus. So that means if x is 0, y is plus or minus 3. Here's what that means ordered pairwise. It means that 0 is paired with the y value of 3, but it also means that 0 is paired with a y value of negative 3. So what's happening right here? You have two ordered pairs that have the same first number. What caused that to happen? The plus minus. What caused that to happen? Because the y was squared at the very beginning. Now, you don't have to do all of that work. All you've got to do is look at that equation, look at y, and if its biggest power, so if y is listed multiple times, don't look at every power of y. For instance, if I have this problem right here, like this problem right here. There's a y here and a y here. You don't look at both powers. You look at the biggest power of y. If the biggest power of y is even, it's not a function. So that right there would not be a function. Now, if this had been 2 instead of 3, now the biggest power of y is odd. So this would be a function. Okay, so that's basically how that works. But you're not going to run into anywhere you have multiple y's in a problem. Now, what was the other dilemma? That y cannot be inside absolute values. Here is y. And that's all you got to remember. I'm just showing you why. Watch what happens if I let y be 7. If I let y be 7, what's the absolute value of 7? It's 7. But what if I let y be negative 7? What's the absolute value of negative 7? It's 7. So see what happens? Because that y is in absolute values, you got two different y's paired with one x. X's are repeating. So, let me say again, all you got to remember is this. Biggest power of y cannot be even, and y can't be inside absolute value bars. So, if you remember that, then you don't have to do any work at all. Let's do 3 examples right here. Write these instructions down. Determine if the following equations are functions. Determine if the following equations are functions. All right, a second here. So let's look at this first example. Example number 1. Okay, this is real easy if you remember the note. So you ask yourself 2 questions. Is y inside absolute values? No. Second question, is the biggest power of y an even power or an odd? That's to the 1. That's odd. That's okay. Then yes, that equation is a function. Now, if you want to solve it for y, you could, but you don't have to. All right, this one right here. Is y inside absolute value symbols? No. Is y the biggest power of y even? No. Then it's okay. That's a function. Now this one. Is the biggest power of y even? Yes. Then that's no. It's not because the y is squared. Okay. Now we want to talk about still equations. So we've talked about how to tell if an equation is a function. Now this is the last part I want to talk about equations. I want to show you how to get the domain of an equation. The domain of an equation. Okay. Let me give you the note first. And then, let's see. Well, let me just kind of ramble for a few minutes and talk to you about something. Remember that domain of an equation, when you're talking about ordered pairs, domain was all of the first numbers. It's the x's. Now, when you're talking about equations, you're not looking at ordered pairs. So you can't just pick the first numbers. Or if you're talking about a graph, how do you find domain? It's how far the graph goes from left to right. But that's not how you get the domain of an equation. Don't write this down. I'm just going to introduce this to you. If I want to find the domain of this equation, what do I mean by that? Well, first of all, remember domain is what the x's can be. It's all the first numbers. Well, I'm not looking at ordered pairs. So how do I know what x is in this problem? Let me explain it to you this way. Let's talk about a Coke machine. A Coke machine is a classic example of something that is a function. Remember, a function says every x is paired with exactly how many? Exactly 1y. Every x is paired with 1y. So 1x always with 1y. I'll give you a couple of examples of things that you see in everyday life that's a function. I've already mentioned one, a Coke machine. When you walk up to a machine and you put your money in and you press that button, how many drinks do you get out? One drink, if it's functioning properly. You've seen these gumball machines in the mall, and you go up and you put a quarter in it, and you turn it and you get one gumball. That's a function. A function, your output is exactly one thing. Your output's like your y value when you're talking about ordered pairs. So 7, 3, 7 is the input, 3 is the output. For instance, in this problem right here, if I let x be 5, what would y be? What's 5 plus 7? 12. So it would be 5, 12. So 5 is the input, 12 is the output. So when you buy a gumball, that one gumball, that's an example of something that is a function. Now, give you an example of something that's not a function. You've put money in a candy machine in the mall and you get a handful of candy. In the mathematical world, that's something that is not a function. You put one thing in and you're getting two things out. So, let's go back to the word domain then. Domain is the x's. The domain is what you're putting in there. So let me talk about the domain of a Coke machine. What is the domain of a Coke machine? You say, well, it's what you put in that Coke machine. You're on the right track, but that's still not exactly right. Remember domain, every x is paired with how many? Exactly 1y. Now, what does exactly 1 mean? No more, and what else? No less. So here's what that means. It means that 7 has to be paired with 4, and 7 can't be paired with any other number other than 4, but 7 has to be paired with a number. See, exactly 1 means it's got to be paired. So here's what you're going to have to stay with me now. I know this gets a little confusing. Domain is not just that first number. That first number has to be paired with another number. And not only that, it has to be paired with exactly one number. So for 7 to be in the domain means two things. It means it's paired with something, and it means it's paired with exactly one something. You say, well, I'm still a little confused. Now, I understand. So you're going to stay with me here. Let's go back to the Coke machine. The domain of a Coke machine is not what do you put into it. Because remember, you have to get exactly one thing out. The domain of a Coke machine is what do you put into it to get out your drink. That's domain. It's not just what you put into it. See, if I walk up to a Coke machine, can I put pennies in a Coke machine? Yes, that's my input. But will I get out a drink? No. If I go up to a Coke machine and pour sand into it, will I get out a Coke or a drink? No. What do I have to put into that machine to get my drink? You say money. You're on the right track, but still not there because pennies is money. So be more specific. What do I have to put into that Coke machine to get out a drink? You either have to put quarters, nickels, dimes, quarters, dollar bills, $5 bills, and I know there's a lot of other extreme cases in this day and age we live in. But you get the point. Domain is what do you put into it, but you got to make sure you get your drink out. Now, here's what I mean by that. If you give me any number for X in this problem, I don't care what it is, I can put it right there and I'll get a Y value with it. For instance, if I let X be 0, Y is 7. That means 0 is in the domain. If I let X be 2.3, Y would be 9.3. Then 2.3 is in the domain. If I let X be negative 7, what's negative 7 plus 7? 0. So that would be negative 7 comma 0. So all three of those numbers, if I plug them in, I get a Y value. Well, you say, well, Mr. Arnold, you can plug any number you wanted to into this problem. That's exactly right. That's why the domain to this problem is all real numbers. And you say, well, then it's going to always be all real numbers. That's not true. Here is why. There are some numbers that if you try to plug it into the problem, you don't get your drink out. Let me show you two examples. You don't have to write these down because I'm going to give this to you in a note in just a minute. Look at these two problems right here. If you give me any number for X, I don't care what it is. You give me any number for X, I don't care if it's a fraction, if it's a decimal, I don't care if it's positive, I don't care if it's negative. You give me any number you want to for X, I can plug it in here and I can work that out and give you the Y value that goes with it. You might not like the Y value, but I can give you a Y value. But there is one number in this problem you can't pick. And here's that number if you don't see it already. It's the number 4. Now, why can I not choose the number 4? All right, put your money in and see if you get out a drink. Okay, so here's my input. Let's put it in. 7 divided by, what's 4 minus 4? 7 divided by 0. Take your calculator and take 7 divided by 0 if you don't know what that answer is. If you take 7 divided by 0 and hit the equal key, it's going to give you an error. Why? Because in mathematics, you can never divide by the number 0. So, what I've done right here, when you plug 4 in here, that's the same thing as walking up to that drink machine and pouring sand into it. Can I pour sand into it? Sure I can, but you won't get a drink. Can I put pennies into it? Sure you can, but you won't get a drink. Can I plug 4 into this problem for X? Sure I can, but I won't get an answer. The reason is in mathematics, we can never divide by the number 0. So if you can't complete the ordered pair, you can't use that number. Now, if I change it to 4.1, it's okay. if I change it to 3.9, if I change it to 0, if I change it to -7, any other number is okay. You say, now wait a minute. Why could we use negatives? Can we use -7 up here? Yes, we can. Because what's -7 plus 7? 0. There's nothing wrong with the number 0. The problem is when 0 is in your what? Denominator. So one of the things with the domain, and I'm going to give this to you in a note in the next video, one of the things that we have to watch out for in domain is we have to make sure that the number we put in never makes this denominator become what? 0. Now, if there's no denominator in it, I'm not worried with it. Now, let me show you what's wrong with this one, and then we'll stop the video. If I let x be 0, what's the square root of 0? 0. If I let x be 9, what's the square root of 9? 3. If I let x be 25, what's the square root of 25? 5. Even if I let x be 11, you say, well, if you plug 11 in here, you don't get an answer. Yes, I do. If I let x be 11, plug that in, what would y be? Square root of 11. And you say, Mr. Rainer, we can't get the square root of 11. Yes, we can. Take your calculator and punch in square root of 11, and you'll see you can get the square root of 11. It's just not a whole number. But your calculator will give you that y value, and that's one number. So this is your drink right here. This is what you put in. There's your drink right there. You say, well, okay, then what kind of numbers can we not put in here? Any negative number. Here's why. Let me pick one. If I put in -4, do I get out an answer? No. You said, whoa, wait a minute, Mr. Rainer, we do get out an answer. Okay, tell me what the answer is. If you put -4 in here, what's the square root of -4? 2 what? 2i. Have you ever plotted an ordered pair on a graph like this where one of the numbers was imaginary? No. So you do get an answer, but it's imaginary. So in essence, you're not getting out an answer. It's not a real number. It's not plottable. It's like saying, okay, I put my sand in and I got out an imaginary drink. So it's not really a drink. So an imaginary number is not a real number. It's not plottable in our coordinate system. So there's two things we have to, that limits what we put into our machine. Number one, we can't allow anything that would cause me to divide by what? 0. And the second thing I can't allow is taking square roots of what? Negative numbers. And that's where we'll pick up. We're still talking about equations. And we're talking about domain of equations. And that will be our next video.